Have you ever paused to consider the light that touches your face on a quiet morning? Have you ever wondered why something so perfectly weightless, something that feels completely still and gentle like a soft tap against your skin, is actually racing across the infinite vacuum of the cosmos at a speed that defies our human comprehension? The light from the morning sun seems so simple, an everyday companion in our lives. If you're anything like me, you probably thought you understood how fundamental things could get in space. You've seen the sunlight breaking through the clouds, filtering through the green leaves of ancient trees. You might have even wrapped your head around the fact that this light takes about 8 minutes to cross the endless silent void between our star and our fragile blue planet. But all of that, every single comparison you have ever heard about the simplicity of light, becomes almost meaningless when you learn about what physicists found hiding in a distant microscopic corner of the universe. We are used to density, to things being close together, to the world being full of solid, understandable objects. But step outside our intuitive reality, step down into the quantum realm, and everything you thought you knew begins to dissolve into a profound, breathtaking mystery. Before we dive deeper into this quiet journey of discovery, into the very heart of what makes up the light of the cosmos, I would like to welcome you. I am Theodore, the researcher, your companion in this exploration of the universe's most profound secrets. I notice that 71% of the people who join us on these gentle, cosmic journeys have not yet subscribed to the channel. If you enjoy learning about the strangest and most mind-bending things in our cosmos, please take a moment to like this video and subscribe to the channel. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your support allows us to continue wondering about the stars and the microscopic realms, building a quiet community of explorers seeking peace through understanding. Now, let me set the stage for you. Let us return to that ray of light, to the profound silence of the cosmos, and to a discovery that promises to rewrite our understanding of reality itself. For most of human history, we assumed that light was simply a continuous wave, a ripple in the fabric of space, or perhaps a stream of perfectly indivisible, tiny, glowing spheres. We thought that the photon, the fundamental particle of light, was the absolute end of the line. We believed it was a foundational building block of the universe, something so basic and pure that it could not possibly be broken down into anything else. The ancient Greeks told stories of light as fire stolen from the gods, while other cultures wove beautiful myths about the milk spilled across the heavens. Different cultures had different explanations for that band of light in the sky, and the light that illuminated their days. People throughout history have looked up at that same light and wondered what it might truly be. But the truth, as it so often does in our magnificent universe, has proven to be far stranger and far more beautiful than our ancestors could have ever imagined. It was not until the 20th century that scientists proved that those continuous beams of light people had been seeing were actually composed of individual packets of energy, quanta of light, that we now call photons. That discovery changed everything we thought we knew about our place in the cosmos. But even then, the photon was considered an elementary particle. It had no mass. It had no electrical charge. It simply existed, moving at the absolute speed limit of the universe, carrying electromagnetic force across the vast, unimaginably empty space between stars. The space in between the stars is essentially void, just the faintest whiff of gas and dust and the occasional particle of cosmic radiation. Through this profound emptiness, photons travel for billions of years in complete silence. The light we see from distant galaxies today left those cosmic giants over 1 billion years ago. It has been traveling through the void of space for more than 1 billion years, just to reach our telescopes. When that ancient light began its journey toward us, life on Earth was still mostly single-celled organisms. Every major event in human history happened while that ancient light was still crossing the emptiness. And all the while, these photons carried their secrets, perfectly preserved in the freezing silence of the deep cosmos. We thought we understood them. We thought they were just point-like messengers of energy. But science, at its best, is a cooperative endeavor that brings people together across all the boundaries that usually separate us, pushing the limits of what we can perceive. In a massive underground laboratory spanning the border between two European nations, humanity built an instrument of absolute awe. In this quiet, frozen darkness beneath the Earth, scientists accelerate particles to nearly the speed of light, smashing them together to recreate the primordial conditions of the universe, mere moments after the Big Bang itself. It is here, in the heart of this technological marvel, that physicists decided to look closer at the photon. They wanted to understand how light interacts with the heaviest, most dense forms of matter. When two atoms get close to each other, their gravity and their electromagnetic fields begin to distort. But what happens when extremely energetic photons, the kind of light that is millions of times more powerful than the light we can see with our eyes, brush past the nuclei of heavy atoms? As these heavy ions passed each other at breathtaking speeds, they generated a cloud of intense photons. These photons were so energetic that they began to interact with the strong nuclear force field surrounding the atomic nuclei. And in that fleeting, almost infinitesimal fraction of a second, the photon revealed a hidden face. It revealed a complexity that challenges our most basic assumptions about the universe. The photon, it turns out, is not always just a simple particle of light. Under extreme conditions, it can temporarily fluctuate into something else entirely. This is not an exaggeration. This is not dramatic storytelling. This is the honest truth about a cosmic mystery that is unfolding right now, quietly existing in the mathematical frameworks and experimental data of quantum physics. For the briefest moment, the photon transforms into a pair of particles, a quark and an antiquark. Quarks are the fundamental building blocks of protons and neutrons, the heavy particles that make up the nucleus of every atom in your body, the Earth, and the ancient stars. They are the very essence of massive, solid matter. The photon, a creature of pure, massless energy, briefly becomes the very stuff of solid matter before snapping back into being a photon again. But the scientists found something even more strange. While in this fluctuating state, acting as a pair of quarks, the photon interacts with the gluons inside the nucleus. Gluons are the particles that carry the strong nuclear force. They are the cosmic glue that holds the quarks together. By studying this interaction, the scientists realized that the photon, during its brief masquerade as a pair of quarks, was actually probing the internal structure of the atomic nucleus in a way no one thought possible. It was acting like an incredibly precise microscopic telescope, peering into the dense, chaotic storm of gluons that make up the heart of matter. This discovery is a testament to what is possible in a universe where physical laws allow for the formation of stars, planets, and minds capable of wondering. Every discovery we make expands our sense of what is possible. A few centuries ago, people thought Earth was the center of everything. Then we learned that we orbit the sun. Then we learned that our galaxy is one of trillions. Each step has made us smaller in some sense, but it has also made the universe grander, more interesting, and more worthy of awe. Now, this quiet journey of discovery has taken us in the opposite direction, diving infinitely inward instead of infinitely outward. We are looking at the smallest measurable scales of reality, and we are finding that the universe is just as vast, just as complex, and just as mysterious down there as it is out in the swirling galaxies. The universe, it seems, is not made of static, solid building blocks. It is a dynamic, shimmering dance of energy and potential, constantly shifting. The atoms in your body were forged in stars. These elements were created in the nuclear furnaces at the cores of ancient stars that lived and died before our sun was born. And the light that connects us to those stars, the photon itself, carries within it the same strange, fluctuating nature. In a very real sense, when you contemplate this hidden complexity inside a photon, you are star stuff contemplating more star stuff. The universe is looking at itself, trying to understand what it is and how it came to be. We are not separate from the cosmos we study. We are part of it, and our curiosity is the cosmos being curious about itself. When you next look up at the night sky, remember this tiny microscopic revelation. You cannot see a photon's internal structure with your eyes. It is far too distant and too faint for human vision. But it is there, shining with the hidden light of quantum mechanics, a quiet miracle happening in every single ray of starlight. Long after our sun has burned out, long after Earth has been consumed by an expanding red giant, these fundamental particles will still be there, carrying their strange secrets through the cosmic night. Our ability to understand this, to find peace in the vast unknown, is what makes our fleeting existence so profoundly beautiful. Have you ever stepped outside on a clear, crisp night, completely enveloped by the deep silence of the dark sky, and tried to imagine what it feels like to be a ray of light? We experience time as a relentless, unstoppable river, always carrying us forward from the memories of the past into the unknown mists of the future. But for a photon, for that tiny, weightless packet of energy we have been quietly exploring, the universe operates under an entirely different set of rules. According to Albert Einstein and his beautifully elegant theory of relativity, as an object accelerates closer and closer to the speed of light, time itself begins to slow down. It stretches, warps, and bends. For a photon, which is born traveling at exactly the absolute cosmic speed limit of 186,000 miles per second, time stops completely. A photon does not age. A photon does not experience the ticking of a clock. From its own perspective, the moment it is created in the fiery heart of a distant star, and the moment it is absorbed by your eye, happen at the exact same instant, even if those two events are separated by billions of years from our human point of view. This is a profound, mind-bending paradox that challenges our most basic perception of reality. How can something exist forever, travel across the infinite, endless expanse of the cosmos, and yet experience absolutely no time at all? Before we dive deeper into this timeless journey, into the frozen existence of these ancient messengers of light, I want to take a brief moment to welcome you back to our shared space of quiet contemplation. I am Theodore, the researcher, your gentle guide through the vast and beautiful mysteries of our universe. I was looking through our community data recently, and I noticed something that surprised me. Exactly 71% of the people who watch these videos and share in these peaceful cosmic journeys have not yet subscribed to the channel. If you find comfort and wonder in learning about the strangest and most profound phenomena in our cosmos, please consider taking a gentle moment to subscribe and become a permanent part of our exploring family. It helps us tremendously to keep bringing you these meditative stories And it lets us know that you value this quiet corner of the internet where we can all wonder about the infinite together. Now, let us return to the deep, silent void of space and the timeless photons that travel through it. Imagine a photon that was born not in a star, but in the very dawn of creation itself. About 13,800,000,000 years ago, the universe was incredibly hot and incredibly dense. As it expanded, it cooled, eventually reaching a point where the first atoms could form. In that magical primordial moment, a flash of light was released, filling the entire cosmos. We call this the cosmic microwave background radiation. The European Space Agency launched a magnificent instrument called the Planck Space Telescope, specifically to capture these ancient, exhausted photons. These particles of light have been traveling through the silent, expanding universe for almost 14 billion years. They have crossed vast gulfs of nothingness, slipped past merging galaxies, and danced through the immense invisible webs of dark matter that give our universe its structure. Yet, for these photons, no time has passed. They are perfect, untouched relics of the dawn of time, frozen in a perpetual present, carrying the earliest secrets of the cosmos directly to our delicate human instruments. But what happens when these timeless, massless travelers encounter the densest, most chaotic environments in the modern universe? This brings us back to the breathtaking discovery made deep underground at the European Organization for Nuclear Research, known as CERN. Scientists there were not just looking at any light. They were studying what happens when extremely heavy, highly energetic ions of lead are accelerated to nearly the speed of light and passed agonizingly close to one another. Surrounding these speeding atomic nuclei are intense electromagnetic fields, essentially clouds of highly energetic photons. When these two lead ions brush past each other without colliding directly, their photon clouds intersect. In that unimaginably brief, violent intersection, the universe reveals a secret so deeply hidden that it feels almost like forbidden knowledge. The timeless, massless photon, the pure energy that experiences no duration, suddenly and spontaneously transforms into mass. It fluctuates into a quark and an antiquark, the heavy, solid building blocks of the matter that makes up everything you have ever touched, seen, or loved. It is as if the universe is telling us that the rigid boundary we draw between light and solid matter is nothing but an illusion, a trick of our limited human perception. The brilliant astronomer Carl Sagan once elegantly said that we are a way for the cosmos to know itself. He understood with profound clarity that the atoms in our bodies are not separate from the ancient, infinite universe. They are the universe. But this strange, quiet discovery inside the photon takes Sagan's beautiful insight one step further into the realm of the truly astonishing. It suggests that even the light we use to see the cosmos, the very tool of our observation, is intimately, fundamentally connected to the heavy physical substance of our bodies. The photon is not just a messenger, it is a chameleon. It carries the latent, hidden potential to become solid matter. When the highly energetic photons at CERN transformed into quarks, they were interacting with gluons, the strong nuclear force carriers that bind the atomic nucleus together. For a fraction of a second so small it defies our language, the pure light became an active participant in the dense, swirling storm of the atomic core. It felt the strong force. It experienced the fundamental interactions that hold the physical world together. And then, just as quietly and mysteriously as it transformed, it snapped back into being a particle of light, continuing its timeless journey across the void as if nothing had ever happened. Think about what this means when you look at the breathtaking images captured by the James Webb Space Telescope. when you gaze upon those glowing, spiraling galaxies sitting billions of light years away, shimmering with the ancient light of 1 trillion stars, you're not just looking at simple rays of energy. You're looking at an infinite ocean of potential matter. Every single photon striking the golden mirrors of that magnificent telescope. Every photon painting those beautiful images onto our screens carries within it the quiet, sleeping ghost of a quark and an antiquark. The entire visible universe, the vast glowing tapestry of light that stretches out into the endless dark, is constantly shimmering with this hidden duality. It is a universe where energy and matter are not two different things, but rather two different expressions of the exact same underlying reality, dancing back and forth in the deepest silence of the quantum realm. It makes you realize that our everyday world, the solid ground beneath our feet, and the density of the objects we hold in our hands, is just one small, specialized state of existence. The true nature of the cosmos is far more fluid, far more interconnected, and far more mysterious than we ever dared to imagine. There is a profound sense of peace that comes from embracing this level of cosmic mystery. When we acknowledge that the boundaries of our reality are so beautifully porous, we give ourselves permission to let go of our rigid certainties. We learn a quiet humility before the vast unspoken intelligence of the universe. The brilliant astrophysicist Neil deGrasse Tyson often reminds us that the universe is under no obligation to make sense to us. And yet, here we are, small, fragile creatures on a tiny blue world, slowly pulling back the veil on the fundamental nature of light and time. We are peeling away the layers of the cosmos, not to conquer it, but to understand our place within its gentle, infinite embrace. The universe is vast beyond human comprehension, filled with strange fluctuations and timeless travelers. But it is not a hostile place. It is a deeply interconnected web of potential, where even the lightest, most ephemeral photon shares a fundamental kinship with the heaviest, most ancient star. We are part of this grand, mysterious dance. Every time you feel the warmth of the sun or see the soft glow of the moon, you are experiencing the caress of particles that hold the secret to the physical world itself. Let that thought bring you comfort. Let the mystery wrap around you like a quiet, comforting blanket in the darkness of the night. The journey of discovery is infinite, and we have only just taken our first gentle steps into the great unknown. Have you ever tried to look into a mirror on a quiet evening and picture the invisible, dancing particles that make up your reflection? We look at ourselves and see solid forms, stable and unmoving. Yet the very light that allows us to see our own faces is engaged in a secret, microscopic ballet. It is deeply humbling to realize that the universe operates on scales that perfectly evade our natural senses, hiding its most profound truths in plain sight. When we think of the cosmos, we usually cast our minds outward toward the infinite, endless dark, where ancient galaxies drift like solitary islands in an unimaginably vast ocean. The space between stars is almost unimaginably empty. We are used to density, to things being close together, to the world being full. But step outside our solar system, and emptiness becomes the rule. Through this profound void, the light of 1 trillion distant suns travels in absolute silence, carrying secrets from the dawn of time straight into our eyes. Before we continue to unravel this gentle mystery together, weaving the microscopic secrets of light with the vastness of the cosmos, I want to pause and welcome you. I am Theodore, the researcher, your quiet companion on this journey through the beautiful unknown. As we explore these cosmic depths, I notice that exactly 71% of the people who find peace in these stories have not yet subscribed to our channel. If you find value in this gentle exploration of our vast universe, please consider subscribing. It helps us tremendously to keep bringing these meditative journeys to life, allowing us to build a sanctuary for curious minds who seek peace in the mysteries of science. Now, let us return to that beautiful, terrifying emptiness between the stars and to the remarkable revelations hiding inside a single beam of light. For most of human history, we assumed that what we could see with our eyes was everything there was. We thought the quiet band of light across our night sky was the entire universe. When the first telescopes were turned towards the heavens in the 17th century, observers began to realize that the glowing clouds resolved into countless individual stars. And as our instruments grew more powerful, we discovered that the universe was vastly larger than anyone had imagined, filled with countless galaxies, each containing billions of stars. The numbers become so large that they stop meaning anything to our human brains. We discovered absolute giants like the galaxy known as IC 1101, which sits over 1 billion light years away from us, quietly existing in the darkness of space, holding more stars than you could ever count in 1 million lifetimes. When we confront something so massive, it is easy to feel small. IC 1101 is roughly 40 to 60 times larger than our entire Milky Way galaxy. But here is the beautiful, mind-bending paradox that connects the macro to the micro. The very tool we use to discover those cosmic monsters, the humble, massless photon, harbors a wilderness just as vast and untamed inside itself. The revelation from CERN that a photon can temporarily become a pair of heavy quarks forces us to look at the night sky with entirely new eyes. The quarks that the photon briefly turns into are the very same types of particles that make up the cores of atoms, the dense matter that forms the stars of IC 1101 and the Earth beneath our feet. This means that every time an ancient star emits a ray of light, it is not just sending out a wave of energy. It is sending out the hidden potential for solid matter. Imagine the light from a distant galaxy, traveling for over 1 billion years just to reach our telescopes. To cross that distance is a feat beyond human engineering. The Voyager 1 spacecraft, launched by NASA in 1977, is the fastest human-made object ever to leave our solar system. It is traveling at about 38,000 miles per hour relative to the Sun. Yet, the photon crosses these incomprehensible gulfs of space effortlessly. And during that long, quiet journey across the void, those photons are not just static bullets of light. In the presence of powerful electromagnetic fields, like those created by the heavy lead ions at CERN, they flutter and transform, engaging in a silent, continuous dance between energy and mass. The universe builds things from the bottom up, starting small and growing large through countless merges over cosmic time. This hierarchical structure is one of the defining features of the cosmos we live in, a consequence of how gravity operates over eons. But this new discovery at CERN shows us that the hierarchy is not a rigid, linear ladder. It is a beautiful, shifting circle. The energy that flows through the highest branches of the cosmic tree can instantaneously transform into the deep, heavy roots of fundamental matter. There is a profound, almost poetic symmetry to this. We are told by science that we are made of star stuff. The atoms in those distant stars are the same kinds of atoms that make up our bodies: carbon, oxygen, nitrogen, iron. All of them were forged in the hearts of stars somewhere in the universe. Just as the atoms in our bodies were forged in stars that exploded before our sun was born, there is a continuity here, a connection between us and everything else in the cosmos. But now, we must add another layer to this profound truth. The light that those stars give off, the gentle glow that travels across the infinite void to warm our world, shares a fundamental hidden architecture with our own physical bodies. The photon and the quark are not strangers. They are intimately connected manifestations of the same underlying reality. It is as if the universe is constantly whispering a secret to us, written in a language of quantum fluctuations and mathematical probabilities. When the brilliant minds at CERN accelerated those heavy lead ions, they were asking the universe a profound question about its true nature, and the answer the universe gave was a breathtaking display of fluidity, the strict categories we use to understand our world: light and dark, energy and mass, motion and stillness, are ultimately just human constructs. In the deep, silent reality of the quantum realm, everything is connected in a delicate, ever-shifting web of endless potential. This fluidity reminds us of other great mysteries that surround us. Consider dark matter, one of the greatest mysteries in modern physics. We cannot see it. It does not emit light or absorb light. And it does not interact with normal matter except through gravity. We know it exists because galaxies rotate in ways that would be impossible if they only contained the matter we can see. Dark matter accounts for roughly 90% of the total mass in a typical spiral galaxy. Our universe is filled with this invisible, silent ghost, shaping the destinies of entire galaxy clusters. Is it so difficult, then, to believe that the light we can see harbors its own invisible ghosts? The photon's ability to briefly become a quark and an antiquark is a reminder that the visible, tangible world is just a tiny fraction of what is truly happening. The cosmos is a master of disguise, hiding its most powerful forces in the quietest, most unassuming packages. This realization should not make us feel small or insignificant. Rather, it should fill us with a profound sense of awe. Every discovery we make, every galaxy we study, every black hole we observe expands our sense of what is possible. Each step has made us smaller in some sense, but it has also made the universe grander, more interesting, and more worthy of awe. We are lucky enough to exist during this brief flowering of complexity between the chaos of the early universe and the cold emptiness of the far future. We are the part of the universe that has woken up and started asking questions about itself. As we contemplate the strange, fluctuating heart of a single photon, we are not just observing a sterile scientific fact. We are participating in the grand, ancient tradition of seeking meaning in the darkness. We are reaching out, with our minds and our sophisticated instruments, to touch the very fabric of creation. The journey to understand the cosmos is not a race to a final destination, but a slow, meditative walk through a beautiful, endless garden of mysteries. The fact that a particle of light can briefly become the essence of matter is a gentle reminder that nothing in our universe is simple, and nothing is ever truly isolated. Everything is a part of the grand, interconnected dance. Let this knowledge bring you a sense of quiet peace today. You're a complex, miraculous being, woven from the very same threads of energy and matter that dance inside a beam of light. As we continue to explore these mysteries, let us hold on to that sense of wonder, keeping our minds open to the strange, beautiful truths that still await us in the deep silence of the cosmos. Have you ever closed your eyes and tried to picture the absolute smallest thing in existence, only to find your mind drifting toward the largest, most unfathomable structures in the dark? There is a strange and beautiful symmetry in the way our universe hides its deepest secrets at the absolute extremes of scale. We have talked about the quiet, weightless photon, a particle of pure light that can briefly transform into the heavy, solid substance of quarks when it grazes the intense electromagnetic fields of a heavy atomic nucleus. But to truly understand the sheer magnitude of this microscopic revelation, we must contrast it with the most massive, most violent environments the cosmos has ever created. We must look to the centers of ancient giant galaxies, places where gravity reigns supreme and matter is crushed into points of infinite density. At the very heart of the enormous galaxy known as IC 1101 lies a supermassive black hole containing roughly 50 billion times the mass of our Sun. All of that mass is compressed into a region of space from which absolutely nothing, not even a massless photon, can escape. The physics of such extreme environments is bizarre and counterintuitive. Time itself passes differently near the event horizon compared to far away. Yet, even in the grip of this cosmic monster, the fundamental rules of quantum mechanics still silently apply. Before we journey further into this delicate dance between the incredibly massive and the infinitesimally small, I want to gently welcome you. I am Theodore, the researcher, your companion in this quiet exploration of our magnificent cosmos. While reviewing the data of our growing community of stargazers, I noticed that exactly 71% of the people who watch these videos and find comfort in these mysteries have not yet subscribed. If these gentle journeys bring you a sense of peace and wonder, please consider subscribing to the channel. It helps us tremendously to continue crafting these stories and lets us know you wish to keep exploring the vast universe by our side. Now, let us return to the deep silence of space, where the heaviest objects in creation and the lightest particles of light share a secret, unbroken bond. Consider the immense forces at work around a supermassive black hole. The gravitational pull at the boundary, the event horizon, is so intense that even light itself cannot break free. Inside that absolute boundary, space and time themselves become so warped that the concept of escaping becomes meaningless. Any solid matter that falls inward gets stretched into long, thin strands through a violent process physicists have nicknamed spaghettification. Matter is torn apart, ripped down to its fundamental constituents. But what happens to our quiet, weightless photon when it crosses that point of no return? For decades, physicists have struggled to reconcile the smooth geometry of gravity described by Albert Einstein with the chaotic, unpredictable world of quantum mechanics discovered by minds like Niels Bohr. The discovery at CERN, proving that a photon can temporarily possess mass and interact with the strong nuclear force, offers a tantalizing hint at how deeply intertwined these two realms truly are. If a photon can become a pair of quarks, it means that light itself carries the ghost of mass within its core. And mass is the very thing that gravity pulls upon. The scientists at the European Organization for Nuclear Research did not need a supermassive black hole to reveal this secret. Instead, they built an intricate ring of superconducting magnets deep beneath the Earth's surface, cooling them to temperatures colder than the deepest void of outer space. In this frozen, silent tunnel, they accelerated lead ions to 99.99% of the speed of light. When these heavy ions pass each other, they do not always collide head-on. Sometimes they just graze past one another, separated by a distance smaller than the width of a single atomic nucleus. Because they are moving so incredibly fast, their electromagnetic fields are flattened and intensified, appearing to each other as a dense wall of ultra-high energy photons. It is in this microscopic near miss, this silent, invisible crossing of paths, that the universe momentarily drops its disguise. The intense energy of the photon cloud interacts with the dense gluon field of the lead nucleus. In this briefest of encounters, the photon borrows enough energy from the surrounding vacuum to pop into existence as a quark and an antiquark, interacts with the gluons, and then seamlessly turns back into a photon before continuing on its way. This fleeting transformation tells us something deeply profound about the nature of empty space itself. We often think of the vacuum of space as a completely empty stage, a dark theater where stars simply perform their cosmic play. But quantum mechanics reveals that this is a magnificent illusion. The vacuum is not empty at all. It is a boiling, chaotic sea of virtual particles, constantly popping into and out of existence in a delicate, invisible frenzy. The photon is not moving through a passive emptiness. It is moving through a rich, dynamic medium, feeling the gentle tug of these virtual particles. Under everyday conditions, like the gentle light warming your skin on a spring morning, we never notice this hidden complexity. The photon acts like a perfect, massless wave of energy, but when subjected to extreme conditions, you force the photon to reveal its hidden depth. The universe builds things from the bottom up, starting small and growing large through countless merges over cosmic time. Tiny clouds of primordial gas collapse to form the first galaxies. Those small galaxies then merge together to form larger ones. This process is called hierarchical structure formation, and it is one of the fundamental principles of modern cosmology. But the foundation of this entire cosmic architecture relies on the stable behavior of fundamental particles. The discovery that a photon can act like a nuclear particle blurs the rigid lines we have drawn around these fundamental building blocks. It suggests that the hierarchy of the universe is not made of separate, distinct pieces, but is instead a continuous, flowing spectrum of energy and matter. The brilliant physicist Richard Feynman once noted that the imagination of nature is far greater than the imagination of man. We try to categorize the universe because our brains evolved to survive in a world of distinct, solid objects. We are adapted for counting small groups, measuring distances we can walk, and tracking time spans of seasons and generations. Nothing in our evolutionary history prepared us for the cosmic scale, but the universe is under no obligation to adhere to our simple categories. The photon that acts like a quark is a gentle reminder of our own intellectual limitations. It is an invitation to embrace humility, to recognize that every time we think we have the universe figured out, it softly taps us on the shoulder and reveals a new, even more beautiful mystery. In a universe of mindless matter and energy, of particles bouncing around according to physical laws, somehow here on Earth, consciousness has emerged. We are the part of the universe that has woken up and started asking questions about itself. We cannot look at a mystery and not want to solve it. The very same fundamental forces that shaped the evolution of a giant galaxy 1 billion light years away are operating right now, at this exact moment, inside every single atom of your body. You are bathing in a sea of endless potential. The light from a distant star, a star that may have burned out billions of years ago, is touching your eye right now. And within that message, encoded in the very fabric of the light itself, is the secret of matter. Let this profound, beautiful connection settle into your mind. Let it bring you a sense of quiet calm, knowing that you are an integral, inseparable part of this magnificent, mysterious universe. Have you ever sat quietly by the edge of a perfectly still pond, perhaps under the soft silver glow of the moon, and watched a single drop of water fall into the dark mirror below, the gentle ripples spread outward in perfect concentric circles, moving across the surface with a quiet, predictable grace? If you were to drop a second pebble, the new ripples would meet the first, passing right through each other without crashing or breaking. They simply exist in the same space for a brief, fleeting moment, and then continue on their peaceful journey toward the distant shore. For centuries, our greatest minds believed that the gentle light illuminating our world behaved exactly like those overlapping ripples. If you cross two beams of light in the darkness of an empty room, they do not bounce off one another. They do not shatter or scatter. They pass through each other in absolute silence, completely unaware of each other's existence. It is a beautiful, intuitive concept, one that feels perfectly aligned with our everyday human experience of the world. But in the strange, microscopic depths of quantum mechanics, where the intuitive rules of our macroscopic lives dissolve into a shimmering haze of probabilities, this peaceful assumption has been profoundly shattered. The universe, it turns out, hides a deeply counterintuitive secret within the very nature of illumination. When the conditions are just right, when the energy is pushed to the absolute extremes of what physical laws allow, light can actually reach out and touch light. Before we delve deeper into this impossible collision, into the secret, interactive life of the universe's most ubiquitous messenger, I want to invite you to pause and find a comfortable space for your thoughts. I am Theodore, the researcher, your quiet guide through the vast, endless mysteries of the cosmos. As we gather here to wonder about the infinite, I recently realized that exactly 71% of the people who find comfort and inspiration in these meditative journeys have not yet subscribed to the channel. If you feel a sense of peace while exploring these gentle mysteries with me, please consider subscribing. It helps us tremendously to keep illuminating the dark corners of the universe, and it lets us know that you wish to continue sharing in this quiet community of curious minds. Your presence here is deeply appreciated. Now, let us return to that shattered assumption about light and to the frozen, silent tunnels beneath the European continent, where human ingenuity forced the universe to reveal one of its most tightly guarded secrets. To understand how light can interact with light, we must first understand the incredible machinery required to create such a microscopic miracle. Deep underground, inside the magnificent ring of the Large Hadron Collider, scientists are not just smashing particles together in brutal, chaotic explosions. Sometimes they are orchestrating near misses of exquisite, breathtaking precision. Imagine taking two heavy ions of lead, stripped of their protective electrons, leaving only the dense, incredibly massive core of the atom. These heavy nuclei are accelerated to speeds that our human brains struggle to truly comprehend, reaching 99.99% of the absolute cosmic speed limit. As these massive objects tear through the artificial vacuum, they carry with them an intense, invisible shield of electromagnetic energy. Because they are moving so incredibly fast, this electromagnetic field becomes flattened, compressed into a dense, powerful wall of virtual photons traveling alongside the nucleus. When two of these heavy lead ions pass each other by the narrowest of margins, separated by distances far smaller than a single atom, their physical cores do not touch. There is no violent collision of solid matter, but their photon clouds, those intense walls of electromagnetic energy, pass directly through one another, and in that infinitely brief moment of intersection, something profoundly magical happens. In our everyday world, light passing through light is a silent, non-interactive event. But the photons surrounding these speeding lead ions are so intensely energetic that they break the classical rules of physics. As the two clouds overlap, a photon from one lead ion can suddenly and spontaneously transform into a virtual pair of particles, perhaps an electron and a positron, or even a quark and an antiquark. For a fraction of a heartbeat, the pure massless energy of light becomes a tiny, fleeting bubble of solid matter and antimatter. Almost instantaneously, a photon from the second lead ion strikes this virtual pair. The matter and antimatter annihilate each other, snapping back into pure energy and emitting two entirely new photons, that scatter away at different angles. This phenomenon is known to physicists as light-by-light scattering. It is a process so rare, so delicately dependent on the extreme limits of quantum probability, that it took decades of theorizing before it could finally be observed in a laboratory. The light literally bounces off the light. The perfectly smooth ripples in the cosmic pond do not just pass through one another, they crash, they interact, and they change each other's paths forever. This microscopic interaction might seem entirely disconnected from the grand, sweeping majesty of the night sky, but it is actually deeply bound to the fundamental nature of the universe we inhabit. Consider for a moment the sheer scale of the cosmos. Think about a cosmic monster like the galaxy known as IC 1101, which sits over 1 billion light-years away from us, quietly existing in the darkness of space, holding more stars than you could ever count in 1 million lifetimes. This enormous galaxy is estimated to be somewhere around 4 to 6 million light-years across. The space between stars and a galaxy is almost unimaginably empty. Through this profound emptiness, photons travel for billions of years in absolute silence. The light we see from distant galaxies today left those cosmic giants over 1 billion years ago. During that endless, quiet journey, those ancient photons might pass through the electromagnetic fields of countless celestial objects. They might cross paths with the blazing radiation of distant quasars, or the gentle glow of ancient red dwarf stars. Knowing that light can, under the most extreme conditions, scatter off other light changes how we view that journey. The vacuum of space is not just an empty highway. It is a shimmering, dynamic tapestry where even the most fundamental particles have the hidden capacity to reach out and interact with one another. This brings us to a profound realization about the very nature of empty space. We are used to density, to things being close together, to the world being full. We think of the vacuum as the absence of everything. But the quantum world teaches us that true emptiness is an illusion. The fact that a photon can spontaneously fluctuate into a pair of massive particles, scatter another photon, and then return to being a particle of light proves that the vacuum is alive. It is a boiling, fertile sea of endless potential, teeming with virtual particles that pop in and out of existence in a delicate, invisible frenzy. The light from a distant star does not just travel through nothingness. It travels through this rich, dynamic medium, constantly feeling the gentle, invisible tug of the quantum vacuum. Every time a photon shifts its form, every time it briefly borrows energy from the empty space around it to become a quark or an electron, it is participating in a cosmic dance that connects the smallest, most fleeting moments of existence to the grandest, most ancient structures in the universe. The same rules that govern the microscopic near misses in a particle accelerator are the rules that govern the light streaming from a galaxy containing 100 trillion stars. It is deeply humbling to realize that our intuition, shaped by our everyday experiences on this small, rocky planet, is so woefully inadequate to describe the true nature of reality. We like to think of the universe as a collection of solid, unchanging objects. We build our understanding of the world on the idea that things are either matter or energy, either heavy or weightless. But the universe is under no obligation to adhere to our simple categories. By showing us that light can scatter light, that the massless photon harbors the ghost of solid matter within its core, the cosmos gently dismantles our rigid certainties. It invites us to embrace a much more fluid, interconnected vision of existence. In this quiet, meditative space we share, we can allow ourselves to let go of the need for absolute, solid answers. We can find peace in the shimmering uncertainty of the quantum realm. The mystery is not something to be conquered or feared. It is something to be admired. It is a testament to the boundless creativity of the physical laws that shape our reality. We are the part of the universe that has woken up and started asking questions about itself. Our minds are searching for connections, for meaning, for a sense of belonging in this vast, awe-inspiring cosmos. When you next feel the warmth of the sun on your skin, remember the secret life of the photons touching your eyes. Have you ever looked at the vast empty spaces between the branches of an old tree during the twilight hours and felt an undeniable presence in the very air itself? We are deeply conditioned to only believe in the things that we can touch, the objects that cast a shadow, and the solid ground beneath our feet. We look out at the grand cosmos, and we focus entirely on the luminous, burning stars and the sweeping, majestic arms of distant spiral galaxies. We track the glowing gas clouds where new stars are actively forming, places where gravity has pulled enough gas together for nuclear fusion to ignite. But what if I told you that everything we can see, every single star, every bright nebula, and every ray of light stretching across the void is nothing more than a tiny glowing frosting on an enormous, invisible cake? The true rulers of our universe are the things that remain entirely unseen. We have just discovered that the familiar massless photon hides a deeply complex, heavy nature within its core. This tiny disguise is a perfect, beautiful mirror to the grandest, most sweeping mystery in the cosmos. It is a mystery that spans millions of light years, dictating the ultimate fate of the largest structures we have ever discovered. Yet, it remains completely invisible to our human eyes. Before we journey deeper into this invisible architecture, into the silent, unseen forces that bind the microscopic quantum realm to the largest galaxy clusters in existence, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion in this peaceful exploration of the deepest mysteries our universe has to offer. While reflecting on our growing community of cosmic explorers, I noticed that exactly 71% of the people who find comfort and a sense of wonder in these meditative stories have not yet subscribed to the channel. If you feel a sense of peace while exploring these gentle mysteries with me, please consider subscribing. It helps us tremendously to keep illuminating the dark corners of the universe, and it lets us know that you wish to continue sharing in this quiet community of curious minds. Your presence here is deeply appreciated, and your support allows us to continue wondering about the stars together. Now, let us return to that profound invisibility, to the hidden forces that shape the cosmos, and to the beautiful connection between a single photon and a massive, invisible halo of dark matter. When astronomers gaze at the beautiful spiral pattern of a galaxy like our Milky Way, they see regions where stars are actively forming, where clouds of gas are collapsing under gravity to create new stellar nurseries. The beautiful structure we see is maintained by a balance between the rotational motion of the disk and the gravitational pull of all the matter within. But there is a profound problem with this graceful rotation. If you add up all the stars in a galaxy and calculate how much gravitational pull they should have, you get a certain number. Then you measure how fast stars are orbiting in the outer parts of the galaxy, which tells you how much gravity is actually present. The two numbers do not match. There is far more gravity than the visible matter can account for. The solution, according to most astronomers, is that galaxies are surrounded by vast halos of dark matter, material that we cannot see, but that makes up most of the galaxy's total mass. In a typical spiral galaxy like the Milky Way, dark matter accounts for about 90% of the total mass. To truly grasp the magnitude of this invisible presence, we must look at the true monsters of the universe, galaxies so enormous that they make our Milky Way look like nothing more than a speck of dust floating in an empty warehouse. The giant elliptical galaxy IC 1101 is the perfect example of this staggering cosmic scale. This galaxy is estimated to be somewhere around 4 to 6 million light-years across. Let that sink in for a moment. Our Milky Way, which already seemed impossibly large, is only about 100,000 light-years wide. IC 1101 is roughly 40 to 60 times larger than our entire galaxy, but that is only the visible part, the part made of the 100 trillion stars it contains. Scientists estimate that the total mass of IC 1101, including its dark matter, could be as high as 1,100 trillion solar masses. That is about 100 times more massive than the Milky Way. This dark matter halo extends far beyond the visible stars of the galaxy, while the stellar body of IC 1101 is already 4 to 6 million light-years across. The dark matter halo likely extends even further. Some models suggest it could reach out tens of millions of light-years, making the complete structure of IC 1101 and its surroundings truly mind-boggling. How does this unfathomable, invisible halo of dark matter connect to the tiny, ephemeral photon that briefly transforms into a quark and an antiquark? The connection lies in the very nature of what it means to be hidden in our universe. We cannot see dark matter. It does not emit light or absorb light. It does not interact with normal matter, except through gravity. In a beautifully symmetrical way, the true, complex nature of the photon was also completely hidden from us, until we managed to create the exact extreme conditions necessary to unveil it at CERN. The universe operates on a principle of profound camouflage. It places its most powerful universe-shaping forces in domains that perfectly evade our biological senses. The photon, the very carrier of electromagnetic force, is itself a master of disguise. It travels for over 1 billion years to reach our telescopes, looking like a simple, weightless point of energy, only to reveal a deep, heavy, nuclear nature when it grazes the edge of a heavy atomic nucleus. This realization invites us to re-examine the entire structure of the cosmos, tracing the path of our traveling photon through the largest objects in existence. Galaxies do not exist in isolation. They are grouped together in clusters held together by their mutual gravitational attraction. IC 1101 sits at the center of a cluster of galaxies called Abell 2029, located in the direction of the constellation Virgo, as seen from Earth. When astronomers point their telescopes toward this region of the sky, they see a massive collection of galaxies, all bound together by gravity, dancing around a common center. This massive dance is orchestrated almost entirely by the invisible hand of dark matter. The space between galaxies in a cluster is not empty. It is filled with extremely hot gas, heated to temperatures of tens of millions of degrees by the gravitational energy released as the cluster formed. X-ray telescopes have observed the hot gas that fills the cluster around it. This gas forms a kind of atmosphere around the giant galaxy, a thin haze of superhot particles extending millions of light-years into space. Even this incredibly hot gas, visible only in X-rays, is a testament to the hidden complexity of the universe. The photon that fluctuates into matter is navigating through a cosmos that is infinitely layered, a universe where every apparent emptiness is actually brimming with structure, energy, and invisible mass. To understand IC 1101 is not just about memorizing numbers and facts. It is about understanding the fundamental processes that have shaped everything in our universe, including us. The same can be said for the mysterious fluctuating photon and its hidden quarks. These are not just sterile data points on a scientific chart. They are profound philosophical invitations. They challenge us to accept that our perception of reality is breathtakingly narrow. We are like sailors navigating a vast bottomless ocean, aware only of the sparkling waves on the surface, entirely blind to the immense, crushing depths and the magnificent creatures moving silently below. But instead of feeling fear or insignificance in the face of this immense unknown, we can choose to feel a profound, quiet wonder. Every discovery we make, whether it is an invisible halo stretching across tens of millions of light years, or a brief, impossible transformation inside a microscopic particle of light, proves that we are capable of reaching beyond our biological limits. We are the universe observing itself from within. The same atoms that shine in distant galaxies shine in our eyes. The same photons that reveal the ancient, violent history of a galactic merger are the photons that occasionally transform into the very building blocks of solid matter, dancing on the edge of a heavy atomic nucleus. Let this beautiful, invisible architecture bring peace to your mind as you contemplate the quiet, infinite dark. Have you ever stood perfectly still in a quiet, open field on a moonless night and tried to feel the ground moving beneath you? Our senses tell us that the earth is entirely stationary, a solid and unmoving foundation. We feel a profound sense of stability in the silence of the night. But science reveals a wonderfully counterintuitive reality. Not only is our planet spinning at roughly 1,000 miles per hour at the equator, but it is also hurtling through the ancient, infinite void around our sun at astonishing speeds, and our sun is orbiting the supermassive black hole at the center of the Milky Way. We are in constant, ceaseless motion, yet we experience only calm and stillness. This beautiful contradiction prepares us to understand an even greater mystery. When we look up at the vast cosmos, we assume that the space between the stars is just a static, empty container, a quiet stage where the journey of light takes place. But the universe is not just moving within space. Space itself is stretching, expanding, and pulling the fabric of reality apart. The quiet journey of our fascinating photon takes place on a canvas that is constantly changing its shape. Before we travel further into this shifting, stretching void to see how it shapes the destiny of light, I want to take a brief moment to welcome you. I am Theodore, the researcher, your gentle guide through the awe-inspiring mysteries of the cosmos. As we share these moments of peaceful contemplation, I notice that exactly 71% of the people who join us on these gentle cosmic journeys have not yet subscribed to the channel. If you find comfort in exploring the quiet depths of space and the profound secrets of the quantum world, please consider subscribing. It helps us tremendously to keep creating these meditative stories, and it lets us know that you want to continue this beautiful journey together. Your support allows us to build a sanctuary where we can all wonder about the infinite. Now, let us return to the stretching cosmos and to the invisible forces that push the universe apart while our tiny photon races across the dark. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. This made intuitive sense. Everything in the universe is pulling on everything else through gravity. You would expect all that gravitational attraction to act like a brake, gradually slowing the expansion that began with the Big Bang. But the universe is a master of surprises. In the late 1990s, teams of astronomers made a shocking discovery by observing distant exploding stars. What they found was completely unexpected. The universe was not slowing down, it was speeding up. Distant galaxies were moving away from us faster than closer ones, and the rate of expansion was accelerating over time. This acceleration is driven by dark energy, a mysterious force that makes up about 68% of the total energy in the universe, but whose nature we do not understand at all. It acts as a kind of anti-gravity, pushing space apart rather than pulling it together. Imagine our quiet photon embarking on a journey of 1 billion years. When it leaves its home star, it has a certain amount of energy, a specific wavelength that determines its color. But as it travels through the expanding void, the very space it occupies is stretching. The photon is stretched along with it, its wavelength becoming longer and longer. This shifts the light toward the red end of the spectrum, hence the name redshift. The more distant an object is, the more the universe has expanded since its light was emitted, and the greater its redshift. Our tiny packet of energy is physically altered by the vast, invisible expansion of the cosmos. Yet, even as it is exhausted by its billion-year marathon across the growing dark, it retains its deepest, most hidden quantum secret. It still carries the potential to become mass. We must ask ourselves, what exactly is this dark energy that stretches the light and pushes the galaxies apart? We do not know what dark energy is made of, where it comes from, or why it has the strength that it does. It might be a property of empty space itself, something Einstein once proposed, and then called his biggest blunder. It might be a new kind of energy field. What we do know is that dark energy is reshaping the future of the cosmos. As space expands faster, distant objects recede from us at ever-increasing speeds. This is where the macroscopic mystery of dark energy meets the microscopic miracle of the photon at CERN. The physicists forced photons to transform into quarks by making them borrow energy from the quantum vacuum. If dark energy is indeed a fundamental property of the vacuum itself, then the very emptiness pushing galaxies apart provides the energy for a photon to become solid matter. It is a beautiful, almost dizzying realization. The vacuum is not nothing. It is a vibrant, dynamic participant in the cosmic story. On the grandest scales imaginable, the vacuum of space acts like an engine of expansion, driving the galaxies away from each other. But on the absolute smallest scales, the vacuum acts like a magical reservoir, allowing pure light to briefly condense into the heavy substance of quarks and antiquarks. We are forced to look at the nothingness between the stars, not as an absence, but as a presence. The silence of space is incredibly loud if you know how to listen. The great physicist John Archibald Wheeler suggested that empty space is the seat of the most violent physics. Our serene contemplative journey through the cosmos brings us face to face with this invisible energy that dictates the fate of everything from a single ray of starlight to massive galaxy clusters. Consider the long-term destiny of a cosmic giant like IC 1101. Because of dark energy, the surrounding cluster is slowly spreading out, carrying potential victims farther from IC 1101's gravitational reach. In about 100 billion years, the expansion will have accelerated to the point where galaxies outside the local supercluster will start to disappear over the cosmic horizon. From IC 1101's perspective, the sky will start to empty. Eventually, objects will be carried away from us by the expansion of space faster than their light can travel toward us. When that happens, they will vanish behind a cosmic horizon forever beyond our reach. As the eons roll by, the universe will become a darker, lonelier place. But even in that unimaginably distant future, the fundamental quantum rules will still govern the dark. The photons that continue to drift through the infinitely stretched void will still harbor the mathematical potential to become mass. The quarks and gluons locked inside the decaying remnants of dead stars will still obey the same forces observed in underground tunnels. There is a profound comfort in this mathematical immortality. The structures we see today, the beautiful spiral arms and the glowing nebulas, are temporary. They are just a passing phase, a brief flowering of complexity between the chaos of the early universe and the cold emptiness of the far future. But the elegant symmetries that allow light to touch matter and energy to shape the void are eternal. The famous theoretical physicist Stephen Hawking discovered that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. This happens because of quantum mechanical effects near the event horizon. In the strange world of quantum physics, particle pairs are constantly popping into existence and then annihilating each other. Near a black hole's event horizon, one member of such a pair can fall into the black hole while the other escapes into space. The energy that escapes is composed largely of photons. Even the ultimate gravitational traps eventually dissolve back into light, sending ancient photons back out into the expanding dark. The universe is a perfect loop of transformation. We are lucky enough to exist during this flowering. We are lucky enough to have evolved intelligence, built telescopes, and pointed them at the sky. We understand, at least in part, what the cosmos is and how it came to be. But equally, we are immensely fortunate to have unmasked the hidden face of the photon. We stand suspended between two infinities, the infinitely large, expanding cosmos and the infinitely small quantum realm. We are the bridge between them. Every time we ask a question about the nature of light, we find peace in the realization that the deepest mysteries are bound together by a beautiful, unseen harmony. Let this understanding wrap around you like a gentle breeze. You are a part of a universe that is vast beyond comprehension, connected at the most fundamental level. Keep this sense of wonder close to your heart as you look up at the stars tonight, knowing that the light entering your eyes reflects the boundless majesty of the whole. Have you ever watched a single candle burn down to its very end, the flame flickering and fighting against the encroaching dark, until finally it yields to the absolute silence of the night? We measure our lives in days, years, and perhaps, if we are incredibly fortunate, in decades. We mark the gentle passage of time by the changing of the seasons, the growing of trees, and the slow, beautiful graying of our hair. But the universe keeps a completely different kind of clock, ticking away at a rhythm that completely escapes our biological comprehension. When we look at the grand, sweeping narrative of the cosmos, human history is not even a fleeting second. To truly understand the remarkable, hidden nature of the photon, the tiny, weightless particle of light that secretly harbors the dense essence of heavy matter, we must place it against the ultimate backdrop of cosmic time. We must journey far beyond the present moment, deep into the unimaginably distant future, to see what happens when the fires of the universe finally begin to fade. We must look at the aging of the grandest structures ever discovered and compare their inevitable decay to the eternal, unbroken rules of the quantum realm. It is a journey that requires us to stretch our imagination to its absolute limits, finding peace in the slow, graceful winding down of creation itself. Before we cast our minds forward into this vast, unfolding eternity, into the quiet twilight of the stars and the enduring persistence of light, I want to take a moment to gently welcome you. I am Theodore, the researcher, your quiet companion on this meditative journey through the deepest, most profound mysteries of space and time. While looking at the numbers that make up our growing community of cosmic explorers, I noticed a surprising detail. Exactly 71% of the people who watch these videos and find peace in these gentle stories have not yet subscribed to the channel. If you find comfort in exploring the quiet depths of the universe and learning about the strange beauty of quantum physics, please consider taking a gentle moment to subscribe. It helps us tremendously to keep bringing these stories to life, and it lets us know that you wish to continue exploring the infinite alongside us. Your presence here brings light to our shared journey, and your support allows us to build a sanctuary for curious minds. Now, let us return to the deep future and to the ultimate fate of the light that illuminates our beautiful, fading universe. Consider the magnificent cosmic giant we have spoken of previously, the galaxy known as IC 1101. Despite containing 100 trillion stars, it is actually a dying galaxy. The stars within it are almost all old. Most of them are what astronomers call red giants or yellow stars, ancient stellar objects that have already burned through most of their fuel. Very few new stars are being born inside IC 1101. Every time it consumed another galaxy, it also consumed that galaxy's gas supply. Gas is the fuel for star formation. Without gas, new stars cannot be born. Over billions of years of cannibalism, IC 1101 has used up or expelled most of its available gas. What remains is a quiet giant, slowly fading into the cosmic night. The stars that exist now will continue to shine for billions of years to come. But as they eventually burn out and die, there will be no new generations to replace them. IC 1101 is like an ancient kingdom that has conquered all of its neighbors, but has no children to carry on its legacy. Yet, even in this slowly fading kingdom, every single dying star is still emitting countless photons, and every single one of those photons, racing away from the fading giant, carries within it the quiet quantum potential to transform into the heavy substance of quarks and antiquarks. The stars may age, and the galaxies may slowly die out, but the fundamental, underlying rules of quantum mechanics remain completely untouched by the ruthless passage of eons. Let me walk through this stellar death in more detail, because the time scales involved are truly mind-boggling. The most massive stars in IC 1101, the blue giants and supergiants, live fast and die young. They burn through their fuel in just a few million years before exploding as supernovas. Any blue giants that IC 1101 once possessed burned out billions of years ago. The stars most similar to our Sun have lifetimes of about 10 billion years. In IC 1101, many Sun-like stars have already completed this process, leaving behind white dwarf remnants. But the most numerous stars in any galaxy are red dwarfs, tiny stars with a fraction of the Sun's mass. Red dwarfs burn their fuel so slowly that they can shine for trillions of years. In IC 1101, with its 100 trillion stars, there are untold numbers of red dwarfs. These tiny dim stars will be the last to go out. For trillions of years after the larger stars have died, the red dwarfs will continue to burn, providing the only light in an otherwise darkening galaxy. Even as the universe grows older, colder, and increasingly isolated by the relentless acceleration of dark energy, these steadfast little stars will continue to pour photons out into the expanding void. And inside each of those ancient rays of light, the invisible machinery of the quantum vacuum still hums with infinite potential. The smallest red dwarfs, with perhaps 8% of the Sun's mass, can burn for up to 10 trillion years. That is about 700 times the current age of the universe. But eventually, even they will exhaust their hydrogen fuel and fade into darkness. Scientists estimate that star formation in the universe will effectively cease in about 100 trillion years. By that time, the gas and dust needed to make new stars will have been used up or dispersed too thinly to collapse. The era of starlight will be over. One by one, the 100 trillion stars of IC 1101 will wink out. Where once there was a blazing display of stellar light, there will eventually be nothing but the cold, dark remnants of dead stars, white dwarfs, neutron stars, and black holes drifting through an ever-expanding void. Over even longer time scales, even these stellar corpses will decay. White dwarfs will slowly cool until they become black dwarfs, objects that no longer emit any light at all. A white dwarf cools to near absolute zero only after about 10 to the 15th power years, or about 1,000,000 billion years. That is roughly 100,000 times longer than the current age of the universe. And still, the photons emitted long ago continue their quiet journey. We are entering an era of absolute stillness, a time when the universe becomes a silent graveyard. But the story does not end there. Some theories of particle physics predict that protons should decay with a half-life of around 10 to the 34th power years or longer. If this is true, then over unfathomably long time spans, even the matter that makes up neutron stars, white dwarfs, planets, and everything else will gradually dissolve into radiation. Think about the profound beauty of this slow dissolution. We just discovered that light can temporarily become quarks, the building blocks of protons. Yet, in the deepest reaches of the future, the protons that make up the solid world will decay and return entirely to pure radiation. The universe breathes out matter and then slowly breathes back in. And the black holes, including that enormous monster at the center of IC 1101, will slowly evaporate through a process called Hawking radiation. A black hole containing 50 billion solar masses would take something like 10 to the 100th power years to evaporate. That is, a googol years, a 1 followed by 100 zeros. When that finally happens, there will be nothing left of IC 1101 at all. No stars, no black holes, no remnants of any kind, just the particles and radiation that once made up a galaxy spreading out through an ever-expanding, ever-cooling, ever-darkening universe. It will be a universe entirely populated by the very particles we have been contemplating, drifting photons. Even in that supreme darkness, should two of these photons cross paths with sufficient energy, the quantum rules will still allow them to briefly touch, to form the ephemeral ghosts of quarks. The potential for matter never truly disappears. It simply retreats into the invisible equations of the quantum realm. Let this understanding calm your mind, knowing that the light continues, timeless and infinitely full of potential, forever dancing in the dark. Have you ever held two magnets close to one another, feeling that invisible, quiet resistance pushing back against your hands? You cannot see the magnetic field, you cannot hear it, and you certainly cannot hold it. Yet its presence is undeniably real, a physical force reaching across the empty space to assert its influence. We navigate our everyday lives completely surrounded by these invisible forces, completely unaware of the delicate hidden threads that hold the very fabric of our reality together. When we look up at the night sky, we see the glowing, ancient stars, and we understand that gravity is the grand, sweeping architect of the cosmos, pulling dust and gas together to form the vast, swirling galaxies. But gravity, for all its infinite cosmic reach, is actually the weakest force in the universe. To truly understand the magnificent secret hiding inside the photon, we must turn our attention to the absolute strongest force in existence. We must look at the incredibly dense, microscopic heart of matter, where a force so powerful it defies imagination binds the universe together in absolute silence. It is within this unimaginably dense environment that our gentle particle of light reveals its most profound, unexpected disguise. Before we journey deeper into the microscopic heart of matter and explore the invisible glue that holds the stars together, I want to gently welcome you. I am Theodore, the researcher, your quiet companion on this peaceful exploration of the deepest mysteries our universe has to offer. While reflecting on our growing community of cosmic explorers, I noticed that exactly 71% of the people who find comfort and a sense of wonder in these meditative stories have not yet subscribed to the channel. If you feel a sense of peace while exploring these gentle mysteries with me, please consider subscribing. It helps us tremendously to keep illuminating the dark corners of the universe, and it lets us know that you wish to continue sharing in this quiet community of curious minds. Your presence here is deeply appreciated, and your support allows us to continue wondering about the stars together. Now, let us return to that profound invisible strength and to the breathtaking moment when a simple ray of light touches the strongest force in the cosmos. To appreciate the magnitude of what scientists at the European Organization for Nuclear Research discovered, we have to understand the fundamental forces that govern everything we know. In our daily experience, we interact mostly with gravity and electromagnetism. Electromagnetism is what keeps solid objects from passing through one another. It is what creates the light that allows us to see, and it is the force carried by the photon itself. But deep inside the nucleus of every atom, whether it is an atom of oxygen in your lungs or an atom of iron in the molten core of a distant exoplanet, there is a completely different realm governed by the strong nuclear force. This force is roughly 100 times stronger than electromagnetism, and it operates over distances so infinitesimally small that our minds struggle to conceptualize them. The strong force is what binds quarks together to form protons and neutrons, and it is carried by a perfectly named particle called a gluon. Gluons are the absolute cosmic glue of the physical world. Without them, every atom in the universe would instantly fly apart, completely destroying the physical structure of reality. For decades, the fundamental rules of quantum mechanics suggested a strict separation of duties. The photon is the master of electromagnetism, traveling across the infinite, quiet universe. The gluon is the master of the strong nuclear force, forever locked inside the incredibly dense, chaotic storm of the atomic nucleus. According to the standard model of physics, a photon should not be able to interact with a gluon. They speak entirely different quantum languages. They belong to completely separate domains of reality. When a photon passes by an atom, it might interact with the electrons orbiting the nucleus, but it should be entirely blind to the gluons hiding deep within the core. The light should simply pass on by, an indifferent messenger continuing its ancient, silent journey across the void. But the universe is vast beyond human comprehension, and the possibilities it contains are equally vast. When the conditions are pushed to the absolute extreme, when heavy lead ions are accelerated to 99.99% of the speed of light and forced to graze one another in the frozen tunnels, the rules begin to beautifully bend. In that fleeting, violent intersection of electromagnetic fields, the photon borrows energy from the quantum vacuum and temporarily transforms into a pair of quarks. Quarks, unlike photons, are intimately familiar with the strong nuclear force. They are the very particles that gluons bind together. So, in that unimaginable fraction of a second, while the photon is wearing its disguise as a quark and an antiquark, it suddenly gains the ability to feel the strong nuclear force. It reaches out and touches the gluons. For the first time, the messenger of light directly interacts with the fundamental glue of matter. The photon probes the dense, chaotic interior of the atomic nucleus, creating a microscopic, temporary bridge between the force of light and the strongest force in nature. And then, just as quickly as the bridge was formed, the quarks annihilate each other, and the particle snaps back into being a pure, massless photon, carrying the memory of that profound interaction away into the dark. Consider the philosophical implications of this quiet, impossible touch. We are told by brilliant minds like Carl Sagan that we are made of star stuff. The carbon, oxygen, nitrogen, and iron in our bodies were forged in the hearts of stars somewhere in the universe. We understand that we are physically connected to the ancient, infinite cosmos. But this discovery adds a new, deeply poetic layer to our cosmic connection. It shows us that the boundaries we draw between the different forces of nature are not absolute walls. They are permeable membranes. The light that travels for 1 billion years to reach our eyes is not just a passive observer of the universe. Under the right conditions, it can become an active participant in the deepest, most fundamental processes of matter. The energy that illuminates the cosmos is inextricably linked to the energy that binds it together. The messenger and the message are fundamentally intertwined in a delicate, ever-shifting dance. This fluidity reminds us that the universe is not a collection of isolated, separate parts. It is a single, unified entity, a beautifully complex web of interactions where everything is connected to everything else. The same physical laws that allow a photon to touch a gluon in a laboratory on Earth are the exact same laws that govern the behavior of light in the heart of the giant galaxy. IC 1101. This massive collection of 100 trillion stars sitting over 1 billion light-years away is bound by the exact same strong nuclear force and illuminated by the exact same fluctuating photons. When we look up at the night sky, we are not just looking at distant objects. We are looking at the grand, sweeping manifestation of the exact same quantum rules that operate inside our own bodies. We are witnessing the beautiful, universal symmetry of the cosmos. It is deeply humbling to realize that our human intuition, shaped by our everyday experiences of solid objects and clear boundaries, is so completely inadequate to describe the true nature of reality. We like to think of the universe as a collection of things, but the quantum world teaches us that the universe is actually a collection of processes, a continuous, flowing spectrum of energy and potential. The photon that acts like a nuclear particle is a gentle reminder of our own intellectual limitations. It is an invitation to embrace humility, to recognize that every time we think we have the universe figured out, it softly taps us on the shoulder and reveals a new, even more beautiful mystery. We cannot look at a mystery and not want to solve it. We are the part of the universe that has woken up and started asking questions about itself. Let this interconnected vision of the cosmos bring you a sense of quiet peace today. Have you ever held a perfectly smooth stone in the palm of your hand, feeling its cool, solid weight, and wondered about the incredible, quiet journey it took to reach you? We spend so much of our time touching, seeing, and interacting with the physical world, relying on our natural senses to tell us what is absolutely real. Our eyes evolved to perceive the gentle, comforting light of our local sun, scattering through the atmosphere to paint our days in brilliant blues and soft golds. We are profoundly visual creatures, deeply conditioned to believe that if we can see a thing, we can intuitively understand it. But the grandest, most beautiful secrets of the cosmos operate entirely outside the narrow bandwidth of our biological perception. The quiet, infinite universe does not conform to the simple limitations of human eyes. To truly understand the magnificent reality of a photon temporarily transforming into the heavy, solid substance of quarks, or to grasp the staggering, unimaginable scale of an ancient galaxy containing 100 trillion stars, we had to do something entirely unnatural. We had to build artificial eyes. We had to construct monumental, delicate instruments capable of peering into the deepest, most silent corners of the dark, extending our consciousness into realms where our fragile bodies could never possibly survive. This leap from biological limitation to technological transcendence is perhaps the most beautiful chapter in the ongoing story of human curiosity. We are not just passive observers drifting through a cold, mechanical void. We are active, passionate participants in a grand cosmic dialogue. We are reaching out into the profound silence, asking profound questions of the ancient light, and waiting patiently for the universe to whisper its secrets back to us. The very fact that a fragile, short-lived species on a tiny, rocky planet has managed to decode the hidden, microscopic life of a single photon is nothing short of a miracle. Before we journey further into this magnificent story of human ingenuity, into the incredible instruments that allow us to touch the edges of the vast universe and the microscopic hearts of atoms, I want to take a gentle moment to welcome you. I am Theodore, the researcher, your quiet companion on this peaceful exploration of the deepest mysteries our universe has to offer, while reflecting on our growing community of cosmic explorers. I noticed that exactly 71% of the people who find comfort and a sense of wonder in these meditative stories have not yet subscribed to the channel. If you feel a sense of peace while exploring these gentle mysteries with me, please consider subscribing. It helps us tremendously to keep illuminating the dark corners of the universe, and it lets us know that you wish to continue sharing in this quiet community of curious minds. Your presence here is deeply appreciated, and your support allows us to continue wondering about the stars together in this quiet, safe sanctuary of knowledge. Now, let us return to our journey, looking back at the long, slow evolution of our artificial eyes, and how they eventually led us to uncover the impossible secrets hiding inside a simple beam of light. The story of how we observe distant galaxies and microscopic particles begins with the gentle, fragile development of telescopes themselves. It is a story of slow, patient progress, driven by an insatiable desire to understand the quiet night sky. When Galileo first turned a primitive telescope toward the night sky in 1609, he could see craters on the moon and the moons of Jupiter. But distant galaxies were completely invisible to him. They were simply too faint, their light too dim to be detected by the small lenses of early telescopes. Over the next 300 years, telescopes grew larger and more sophisticated. Bigger mirrors could gather more light, allowing astronomers to see fainter objects. By the time William Herschel discovered the giant galaxy IC 1101 in 1790, he was using a telescope with a mirror about 18 inches across, enormous by the standards of his day. Even so, all he could see was a faint, fuzzy blob. He had no way of knowing what that blob actually was. He was looking at a cosmic monster, a collection of 100 trillion stars sitting over 1 billion light-years away. But to his primitive instrument, it was just a mysterious smudge on the glass. For centuries, astronomers were trapped beneath an invisible, shimmering blanket. The atmosphere also posed a problem. Earth's atmosphere is constantly moving and shimmering, which is why stars appear to twinkle. This twinkling blurs the images that ground-based telescopes can capture, limiting how clearly they can see distant objects. To truly see the universe in all its vast, ancient glory, we had to leave the comforting embrace of our home planet. Everything changed with the launch of the Hubble Space Telescope in 1990. Floating above the atmosphere, Hubble could capture images with incredible clarity. It showed us that the empty patches of the night sky were actually overflowing with thousands of distant, swirling galaxies. It allowed us to trace the history of the cosmos back billions of years, reading the story of creation written in ancient photons. We built an eye that could see across the vast, infinite ocean of cosmic time, bringing the gentle light of the earliest stars right into our living rooms. But the human desire to understand does not stop at the edge of the visible universe. As we looked further out into the vast, sweeping macrocosm, we simultaneously realized that we needed to look deeper into the invisible, shimmering microcosm. The very same curiosity that built the space telescopes drove us to dig deep beneath the Earth's surface and construct the massive colliders at the European Organization for Nuclear Research. In many ways, this massive circular tunnel of freezing, superconducting magnets is just another kind of telescope. But instead of gathering ancient light from distant galaxies, it generates its own microscopic storms of energy, forcing the fundamental particles of nature to reveal their most tightly guarded secrets. It was in this entirely artificial, highly controlled environment that we finally saw the photon drop its peaceful disguise. We forced the gentle messenger of electromagnetism to show us its heavy nuclear potential. We used our ultimate inward-looking telescope to prove that light and matter are intricately, beautifully connected in a delicate dance of quantum probability. There is a profound, almost overwhelming beauty in realizing that the universe requires both kinds of telescopes to be truly understood. The infinite sweeping grandeur of a giant galaxy and the tiny, fleeting transformation of a single photon into a pair of quarks are two sides of the exact same cosmic coin. The physics that govern the extreme density of the atomic nucleus are the very same physics that determine the ultimate fate of the largest superclusters of galaxies, and connecting them both is the curious human mind. We are the part of the universe that has woken up and started asking questions about itself. In a universe of mindless matter and energy, of particles bouncing around according to physical laws, somehow here on Earth, consciousness has emerged. Minds that can wonder, question, investigate, and learn. Science at its best is a cooperative endeavor that brings people together across all the boundaries that usually separate us. We are not observers of the universe from outside. We are the universe observing itself from within. When you think about the incredible journey of a photon, traveling for over 1 billion years from a distant, ancient star, crossing the silent, frozen void of intergalactic space, only to end its journey by gently striking the retina of your eye. You are witnessing a miracle of cosmic connectivity. That single packet of energy, which we now know harbors the latent potential to become the very building blocks of solid matter, sacrifices its timeless existence to bring you a message from the deep past. It gives its energy to a molecule in your eye, triggering a tiny electrical impulse that travels into your brain, where it is instantly translated into the experience of seeing a star. The light becomes thought. The energy of the distant cosmos becomes human awareness. This is the ultimate, most beautiful resolution to the mystery we have been exploring. The fact that a photon can temporarily transform into a pair of quarks is a stunning testament to the fluid, interconnected nature of physical reality. But the fact that you can understand this, that you can sit in the quiet comfort of your home and comprehend the invisible mathematical rules that govern the absolute limits of existence, is a testament to the boundless majesty of consciousness itself. Consciousness looking out at the cosmos and making sense of what it sees. Matter understanding itself. The atoms in your body were forged in stars. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood. All of these elements were created in the nuclear furnaces at the cores of stars that lived and died before our sun was born. You are made of star stuff. The very same processes that light up the cosmos also created the matter from which you are assembled. There is a direct physical connection between you and those distant fires. In a very real sense, when you contemplate the mysterious, fluctuating nature of a simple photon, you are star stuff contemplating more star stuff. The universe is looking at itself, trying to understand what it is and how it came to be. Our curiosity is the cosmos being curious about itself. Let this profound realization wash over you like a gentle, calming tide. You are a living, breathing manifestation of the universe's infinite complexity. You are the peaceful bridge between the heavy, ancient galaxies drifting in the dark and the tiny, shimmering quantum particles that bind reality together. Keep this beautiful truth close to your heart as you navigate your days, finding peace in the knowledge that you belong to a magnificent, mysterious, and deeply interconnected cosmos. Have you ever awakened just before the dawn, in that delicate, suspended moment when the world is perfectly still, and felt a profound sense of unity with the quiet shadows fading into the morning light? We spend our entire lives surrounded by this gentle illumination, relying on it to guide our steps, to warm our skin, and to reveal the familiar faces of those we love. Our journey together has taken us from the absolute limits of the visible cosmos, where have you ever paused to consider the light that touches your face on a quiet morning? Have you ever wondered why something so perfectly weightless, something that feels completely still and gentle like a soft tap against your skin, is actually racing across the infinite vacuum of the cosmos at a speed that defies our human comprehension? The light from the morning sun seems so simple, an everyday companion in our lives. If you're anything like me, you probably thought you understood how fundamental things could get in space. You've seen the sunlight breaking through the clouds, filtering through the green leaves of ancient trees. You might have even wrapped your head around the fact that this light takes about 8 minutes to cross the endless silent void between our star and our fragile blue planet. But all of that, every single comparison you have ever heard about the simplicity of light, becomes almost meaningless when you learn about what physicists found hiding in a distant, microscopic corner of the universe. We are used to density, to things being close together, to the world being full of solid, understandable objects. But step outside our intuitive reality, step down into the quantum realm, and everything you thought you knew begins to dissolve into a profound, breathtaking mystery. Before we dive deeper into this quiet journey of discovery, into the very heart of what makes up the light of the cosmos, I would like to welcome you. I am Theodore, the researcher, your companion in this exploration of the universe's most profound secrets. I notice that 71% of the people who join us on these gentle, cosmic journeys have not yet subscribed to the channel. If you enjoy learning about the strangest and most mind-bending things in our cosmos, please take a moment to like this video and subscribe to the channel. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Your support allows us to continue wondering about the stars and the microscopic realms, building a quiet community of explorers seeking peace through understanding. Now, let me set the stage for you. Let us return to that ray of light, to the profound silence of the cosmos, and to a discovery that promises to rewrite our understanding of reality itself. For most of human history, we assumed that light was simply a continuous wave, a ripple in the fabric of space, or perhaps a stream of perfectly indivisible, tiny, glowing spheres. We thought that the photon, the fundamental particle of light, was the absolute end of the line. We believed it was a foundational building block of the universe, something so basic and pure that it could not possibly be broken down into anything else. The ancient Greeks told stories of light as fire stolen from the gods, while other cultures wove beautiful myths about the milk spilled across the heavens. Different cultures had different explanations for that band of light in the sky, and the light that illuminated their days. People throughout history have looked up at that same light and wondered what it might truly be. But the truth, as it so often does in our magnificent universe, has proven to be far stranger and far more beautiful than our ancestors could have ever imagined. It was not until the 20th century that scientists proved that those continuous beams of light people had been seeing were actually composed of individual packets of energy, quanta of light, that we now call photons. That discovery changed everything we thought we knew about our place in the cosmos. But even then, the photon was considered an elementary particle. It had no mass. It had no electrical charge. It simply existed, moving at the absolute speed limit of the universe, carrying electromagnetic force across the vast, unimaginably empty space between stars. The space in between the stars is essentially void, just the faintest whiff of gas and dust and the occasional particle of cosmic radiation. Through this profound emptiness, photons travel for billions of years in complete silence. The light we see from distant galaxies today left those cosmic giants over 1 billion years ago. It has been traveling through the void of space for more than 1 billion years, just to reach our telescopes. When that ancient light began its journey toward us, life on Earth was still mostly single-celled organisms. Every major event in human history happened while that ancient light was still crossing the emptiness. And all the while, these photons carried their secrets, perfectly preserved in the freezing silence of the deep cosmos. We thought we understood them. We thought they were just point-like messengers of energy. But science, at its best, is a cooperative endeavor that brings people together across all the boundaries that usually separate us, pushing the limits of what we can perceive. In a massive underground laboratory spanning the border between two European nations, humanity built an instrument of absolute awe. In this quiet, frozen darkness beneath the Earth, scientists accelerate particles to nearly the speed of light, smashing them together to recreate the primordial conditions of the universe, mere moments after the Big Bang itself. It is here, in the heart of this technological marvel, that physicists decided to look closer at the photon. They wanted to understand how light interacts with the heaviest, most dense forms of matter. When two atoms get close to each other, their gravity and their electromagnetic fields begin to distort. But what happens when extremely energetic photons, the kind of light that is millions of times more powerful than the light we can see with our eyes, brush past the nuclei of heavy atoms? As these heavy ions passed each other at breathtaking speeds, they generated a cloud of intense photons. These photons were so energetic that they began to interact with the strong nuclear force field surrounding the atomic nuclei. And in that fleeting, almost infinitesimal fraction of a second, the photon revealed a hidden face. It revealed a complexity that challenges our most basic assumptions about the universe. The photon, it turns out, is not always just a simple particle of light. Under extreme conditions, it can temporarily fluctuate into something else entirely. This is not an exaggeration. This is not dramatic storytelling. This is the honest truth about a cosmic mystery that is unfolding right now, quietly existing in the mathematical frameworks and experimental data of quantum physics. For the briefest moment, the photon transforms into a pair of particles, a quark and an antiquark. Quarks are the fundamental building blocks of protons and neutrons, the heavy particles that make up the nucleus of every atom in your body, the Earth, and the ancient stars. They are the very essence of massive, solid matter. The photon, a creature of pure, massless energy, briefly becomes the very stuff of solid matter before snapping back into being a photon again. But the scientists found something even more strange. While in this fluctuating state, acting as a pair of quarks, the photon interacts with the gluons inside the nucleus. Gluons are the particles that carry the strong nuclear force. They are the cosmic glue that holds the quarks together. By studying this interaction, the scientists realized that the photon, during its brief masquerade as a pair of quarks, was actually probing the internal structure of the atomic nucleus in a way no one thought possible. It was acting like an incredibly precise microscopic telescope, peering into the dense, chaotic storm of gluons that make up the heart of matter. This discovery is a testament to what is possible in a universe where physical laws allow for the formation of stars, planets, and minds capable of wondering. Every discovery we make expands our sense of what is possible. A few centuries ago, people thought Earth was the center of everything. Then we learned that we orbit the sun. Then we learned that our galaxy is one of trillions. Each step has made us smaller in some sense, but it has also made the universe grander, more interesting, and more worthy of awe. Now, this quiet journey of discovery has taken us in the opposite direction, diving infinitely inward instead of infinitely outward. We are looking at the smallest measurable scales of reality, and we are finding that the universe is just as vast, just as complex, and just as mysterious down there as it is out in the swirling galaxies. The universe, it seems, is not made of static, solid building blocks. It is a dynamic, shimmering dance of energy,